Today we're going to take a look at some tricky substitution problems. And the reason they're tricky is because when they have polynomial pieces in them, the two polynomials that you see tend to have the same degree. So doing the derivative of one doesn't usually help you to eliminate the other from the problem. So let's take a look at example number 1. Let's find the antiderivative of x times the cube root of x minus 4. So what we figured out last time was, generally speaking, your u is going to be whatever is inside of another function. So here, I'm going to let u be equal to what's inside of the radical, x minus 4. Given that, what would du be? What's the derivative of x minus 4? Well, the derivative of that is just 1, and then dx. So here, du is equal to dx. So the dx in the original problem right here is going to just become a du. And what's inside the radical is going to become just a plain old u. The problem is, what's going to happen with this x out here? And this is where an extra step is going to come into play. I'm going to take this equation u equals x minus 4 and rewrite it so it says x equals. So in other words, I need to add 4 to both sides to get x by itself. So x is also equal to u plus 4. At this point, we are now ready to rewrite the integral. So here's what we're going to end up with. Our integral, the x at the beginning is now going to be a u plus 4. The radical stays the same, but what's inside of the radical is now a u and nothing else. And then we have a du at the end. Now we've actually done problems like this before. They were just x's, so we treat it like it's all the u's are x's. First thing we need to do is rewrite so that we have a fractional exponent. U to the 1/3. And then I need to distribute that. And then I'll be able to use the power rule. So let's see, u to the first times u to the 1/3 is u to the 4/3. And then 4 times u to the 1/3 is 4u to the 1/3. And then I have a du at the end. Now I'm ready to use the power rule for antiderivatives. So here we go. The antiderivative of u to the 4/3, I'm going to do it down here, is u, add 1 to the exponent to get 7/3. And then I have to divide by 7/3 or multiply by its reciprocal. And now for the second part, I keep the 4, keep the u. I need to add 1 to the exponent 1/3 to get 4/3. And then divide by 4/3 or multiply by its reciprocal, 3/4. And then have a plus c. Now remember, you're allowed to keep fractional exponents as long as they're positive. So the first term is 3/7 u to the 7/3, or 3/7 times, u was x minus 4, so I put in x minus 4 to the 7/3. And then I have plus. Now 4 times 3/4 is really just 3. And then I have u to the 4/3. That'll be x minus 4 to the 4/3. And then I just need a plus c at the end, and the problem is complete. So this is your final answer. We are going to take a look at another similar example in class tomorrow. Now let's take a look at a tricky substitution problem involving trigonometry. So here we have to find the antiderivative of sine 2x times cosine cubed of 2x dx. So what are we going to choose for u here? Now what I notice is I have this exponent here, which means I really have the cosine of 2x quantity cubed. Well, I don't want to write out cosine 2x times cosine 2x times cosine 2x, so I'm going to make that my u. So we're going to let u equal cosine of 2x, and then that term will become u cubed instead of cosine 2x cubed. We have to come up with the derivative of that, du. Now, before I do that, let's backtrack for a minute. And we had written down before this pattern. We had sine x, cosine x, negative sine x, negative cosine x. And that we know that going down are derivatives and going up are antiderivatives or integrals. So if I want the derivative of cosine, I start at cosine and I go down 1 to get to negative sine. So du is negative sine of 2x. But since it's not just an x inside, it's a 2x, I have to do times the derivative of 2x, which is 2, and then the dx. So du is equal to negative 2 sine 2x dx. Now I have something very similar to that in the original problem. I have sine 2x in dx, and there's sine 2x dx. I need to get rid of the negative 2. So I'm going to go through and divide by negative 2 on both sides, or multiply by its reciprocal. So I'm going to end up with negative 1/2 du is equal to sine 2x dx. And that is what I'm going to use to rewrite my integral. So here we go. The negative 1/2 is going to go out in front. Then I'm going to have my integral sign. Instead of writing the sine 2x dx, I'm writing the negative 1/2 in the du, so I can put a du at the end. And now, instead of writing cosine of 2x cubed, cosine 2x is the same as u from over here. So now I'm just going to have u cubed du. And that will be a very basic power rule for antiderivative problem. Keep the negative 1/2, keep the u, add 1 to the exponent, divide by the new exponent, and then write plus c. So if I do negative 1/2, and then I have this u over 4, that's negative 1/8. And then u is the cosine of 2x. I'm going to raise that to the 4th power. So you can write it in one of two ways. You can do parentheses, cosine 2x, close parentheses to the 4th. Or you can write your final answer as negative 1/8 cosine to the 4th of 2x plus c. Either answer is acceptable. We're going to take a look at one more trig example in class tomorrow. So that's it for tonight, and we'll do a few more tomorrow before we try some more practice problems.